So welcome back again, students. We are going to solve more examples depending on a reducible method. Yesterday we have seen a simple example. Now the examples will be going somewhat matured examples are coming now. What they have done? We have done very simple examples yesterday. Today we are doing more deep examples. So what they have given now? They have given two equations again. 10 upon x plus y, 2 upon x minus y is equal to 4. And 15 upon x plus y minus 5 upon x minus y is equal to minus 2. Equation 1 and equation 2. Correct? Now, we can write the same same equations with rearrangement. 10 into 1 upon x plus y, yesterday we have written it, plus 2 into 1 upon x minus y is equal to 4, and 15 into x 1 upon x plus y minus 5 into 1 upon x minus y is equal to minus 2. Got it? Now, these things, these two variables, we can write in another alphabets. So, we have put 1 upon x plus y is equal to a, and 1 upon x minus y is equal to b. Now, new equations will be 10a plus 2b is equal to 4, and 15a minus 5b is equal to minus 2. See, these two equations 3 and 4 don't have any common coefficient. So, to bring common coefficients, we have to multiply both equations by some numbers. So to bring same coefficients, multiply equation 3 by 5, and equation 4 by 2. Equation 3 by 5 and equation 4 by 2. Then final equations will be 10 into 5 50, 2 into 5 10, 4 into 5 20. Similarly, 15 2s are 30, minus 5 2s are minus 10, and minus 2 2s are minus 4. These are the final equations we got after multiplying them. So check middle term have same coefficient but opposite sign. Same coefficients but opposite sign. When simultaneous equations have same coefficient and opposite sign, we have to add the equations. You must be knowing this. So add equation 5 and 6. Add equation 5 and 6. Added. The opposites will get cancelled. The opposite will get cancelled. 50 plus 30, 80. 80a is equal to 20 minus 4, 16. 80a is equal to 16. So A is equal to 16 upon 80, and final we got A is equal to 1 upon 5. Putting that value of A in equation 3, to find the value of B. So this is the value, 10 into 1 upon 5 plus 2B is equal to 4. 5 ones are 5 twos are. So 2B plus 2 plus 2B is equal to 4. 2B is equal to 4 minus 2, and B is equal to 2 upon 2, and B is equal to 1. These are again the values of A and B, which are not in our original equations. We have to find x, a value of x and y. Value of x and y. So again, resubstitute, you can check the word resubstitute. Resubstitute, A is equal to 1 upon x plus y, and B is equal to 1 upon x minus y. So we got 1 upon x plus y is equal to 1 upon 5, and 1 upon x minus y is equal to 1 upon 1. 1 upon 1 is 1. So these are the final equations. Cross multiply, you will get these things. Cross multiply, you will get this. And these are equation number 7 and 8. That's why I told you these examples are deeper and deeper. So lastly we got equation 7 and 8. Check the variables. Plus y, minus y. When variables are opposite, we have to add. Added. Y got cancelled. X plus x, 2x is equal to 6. So x is equal to 6 upon 2, 3. The value of x is 3. Putting that value of x is equal to 3 in any one of these equations. So we have put in equation 8. So x minus y is equal to 1. So x, value of x is 3. 3 minus y is equal to 1. So this is minus y is equal to 1 minus 3. That plus 3 become minus 3. You have to be very careful in sign changing, otherwise the whole efforts will be in the vain. Unnecessarily your marks will be cut. Minus y is equal to minus 2. And lastly, dividing both sides by minus 1, because variables cannot be negative. Never. Variables cannot be negative. Remember these things. So dividing both sides by minus 1, we got final answer y is equal to 2. And this is the solution set. X is equal to 3 and y is equal to 2. Very simple, brief revision as usual. The given equations are very tedious. We made them linear equations by substituting different alphabets for their different things. Different alphabets for given ratios. These two ratios. After that, we got linear equations 3 and 4. Those are not having same coefficient. To bring same coefficient, what we have done? We have multiplied equation 3 by 5 and equation 4 by 2. Depending on situation, you can use different numbers for different examples. Not necessary always use same numbers. So these are the new equations: 50, 10, 30, minus 10. 10 minus 10 opposites. When opposite variables, opposite coefficients are there, we have to add. We have added 80a is equal to 16, and lastly a is grown upon 5. That value of a we put in equation 3. So we got here value of b, but these are values of b, a and b. We need values of x and y. So again, as usual, see again I am putting the light, and you can check here. So resubstitute values of a and b. We got this one. When you cross multiply, you get equation 7 and equation 8. And checking here again variables, we got two opposite variables. What? Two opposite variables. When you add them, they will get cancelled, and you will get 2x is equal to 6. X is equal to 6 upon 2, that is 3. X is equal to 3. This value we have put any one of these. You can put in this and you can put in this. Depends. So x minus, we have put in equation number 8. So x minus y is equal to 1. And finally we got y is equal to 2. Remember, dividing by minus 1, the variables cannot be negative in any case. To convert them positive, we have to divide both sides by minus 1. We have divided by minus 1 and we got final answer y is equal to 2. And this is the solution set. I am solving extra examples depending on this while our classroom will be resumed. But at present, these examples are very useful to solve you such examples. More than 4 types are there. We have not taken the graphical method. Reason, we are not having the graph books at present, and it is very proper way when the graph books will be in front of you and you can do the things personally in the graph book. So this is the final one more example of resubstituting type. We'll see more examples in coming lectures. Best of luck.